Hello and welcome to session 2 of the Uncrewed Systems Virtual Conference, enabling C5ISR payloads at the edge on autonomous platforms. My name is John McHale, Group Editorial Director with Military Embedded Systems, the SOSA Special Edition, and the FACE Special Edition. I'm also moderator for today's event. To learn more about Military Embedded Systems, please visit militaryembedded.com and check out our articles, blogs, and podcasts on military technology. Our speaker for this session is Mr. Rodger Hoskings, Director of Sales, Mercury Systems, Saddle River, New Jersey. The Uncrewed Systems Virtual Platinum sponsor is Wind River, and the event is hosted by Military Embedded Systems Online and Open Systems Media. Before we begin, I just want to go over some housekeeping items. This and all Open Systems Media virtual events are copyrighted and may not be recorded or used in any way without the express written consent of Open Systems Media. The session will consume about 40 to 45 minutes, leaving the remaining time for Q&A. Now let me show you around the console. You'll find on that right-hand side an area where you can enter those questions in real time. We encourage you to ask as many questions as you can think of throughout the session while it's still fresh in your mind, and we'll address as many as we can during the closing Q&A. If you have a question pertaining to the event operation itself, one of our technicians will get back to you during the session. And please note, as much as we'd like to, we may not get to all your questions today. In that case, someone may get back to you after the event with more information. Now, on the other side of your screen, on the left-hand side, there's a resources section. That's where you can find the slides being presented today. Below that, you can also view today's speaker information. Got two more console features to share with you. The console is customizable insofar as you're able to manipulate all of these widgets, Q&A, resources, and presenters for the ideal viewing experience. You can expand them to get a closer look or close them to have the presentation window automatically resize around them. For maximum screen size, close them all and or use the full screen control in their upper right-hand corner of the presentation window. To bring them back, simply click on the buttons in the bottom middle dock. We also have closed captioning in nearly a dozen languages. To enable this, just simply click on CC in the upper right-hand corner of the presentation window and select your language of choice from the drop-down menu. This session and event will be archived online at the same URL you used to join today's live session and be available within 48 hours. Once up, it is available for at least 1 year. Now I'm pleased to turn over to Rodger. Rodger, take it away.
Great. Thanks a lot, John. Pleasure to be here today. And today we're going to talk a little bit about edge computing and some new technologies that enable those functions for autonomous vehicles. So we're going to start out with just taking a look at the topics. We're going to go over SOSA real quickly because I know you've probably heard a lot about SOSA already, just to review, and then take a look at some of the real special needs of uncrewed systems and how SOSA can help solve those uncrewed or autonomous system problems very, very nicely. What does it mean? What does it mean? SOSA mean for vendors and customers, and then some takeaways. So let's just go through a quick look at MOSA, Modular Open Systems Approach. Basically, it's completely focused on benefiting US DoD, all of the different functions within that organization to enhance competition, stimulate new technology, innovation, save costs, and to improve interoperability. The whole idea is to make new technologies deployable much more easily and in a more standardized way than was ever done before with proprietary solutions that didn't tend to be upgradable. So as a result of that initiative, the three services in DoD, the Air Force, the Army, and the Navy, all developed their own versions of what open systems means to them. And they used the popular standards, adopted parts of them, and they evolved into three different specifications, if you want. What happened then is they saw that there was a lot of commonality. For example, a lot of them used the same software. They used OpenVPX and other common features. It was decided then that they should try to align those three different initiatives into a single initiative, which turned into SOSA, which is a consortium formed under the Open Group. And that then carries forward the best parts of all of those three initiatives into a unified standard called SOSA. So let's go forward and just take a look at what SOSA does. A main product of SOSA is a standard, the technical standard. It's currently revision level 2, snapshot 2, which was just released last month in actually February 2024. So what does it do? It defines hardware, software, and electromechanical functions. And primarily, it's intended for worldwide distribution so that both US and foreign organizations can use it, but the only members of SOSA must be US persons. And what's happening now is the procurement activities are beginning to specify SOSA when more and more of the new bids, the new requirement specifications, and they're more and more leaning towards SOSA should be a requirement in offerings made by, say, prime contractors and other vendors to the government so that they'll be more favorably received and then ultimately win that bid. So, uncrewed vehicles, as it turns out, is the world's fastest growing class of defense platforms. And you all can believe it because you see so much in the news about drones and other types of autonomous vehicles being deployed instead of deploying troops and people, putting people at risk. So this is definitely a huge, major shift in how defense platforms are evolving. And of course, there are many different types of unmanned or uncrewed vehicles: airborne, seaborne, on surface, under the surface, and of course on land. And they're in so many different shapes and sizes. Here's some examples here on the screen. So, but what are some of the most critical requirements for uncrewed vehicles? Of course, SWaP, size, weight, power. And of course, they have to operate in rather often dangerous or hazardous areas. So they have to be very rugged. And they have to be able to handle a lot of different types of sensors: optical, infrared, radar, communications, networking, they need GPS, uh, environmental, inertial sensors, fire control, targeting sensors. So it's a real broad class of what the sensor function needs to be. And in most cases, a uncrewed vehicle will have most or many of those different types of sensors all operating in parallel. In order to take advantage of the latest technology for processing that sensor information, people are moving more and more towards using artificial intelligence and machine learning technologies. So the autonomous vehicle can be adaptive to situations that arise, things that perhaps it never was intended to see, but all of a sudden it's there. What is that vehicle going to do? Is it going to ignore it? Is it going to classify it? Is it going to take more information about it? Those decisions do require artificial intelligence, machine learning, because there's no pilot on board, of course, to make that decision a human one. So it's definitely moving. A lot of the operation of sensor information is now being handled increasingly with AI and machine learning. Some other critical requirements for uncrewed vehicles is the signals that are being acquired in those sensors uh, need to have higher dynamic range, the more accuracy to be able to detect small signals in the presence often of very high power signals. The signals are getting more and more complex. The bandwidths of those signals are getting wider and wider to get more information. Signal frequencies can go, for example, radar and EW can go up to 300 gigahertz, covering all of the, very important military bands from HF all the way over up to millimeter wave frequencies. And one of the other very common features in these kinds of systems are AESA, or active electronically steered antennas, to do beamforming and perform functions like synthetic aperture radar. And in this case, of course, multiple antenna elements work in conjunction with each other, synchronizing each of the channels so that the beamforming algorithms can be computed, and then the beam effectively can be steered in the direction for reception and for transmission. Very important for modern systems. SOSA draws really heavily from OpenVPX, and it defines what goes on in the backplane, the power, and so forth. And it does try to standardize on voltages and the cooling methods and so forth, the protocols, the plug-in card profiles. And in doing that, it adopts certain specs from different parts of specifications of the VITA specification for OpenVPX. And you can see there's card specifications. There are mechanical power and thermal management for different types of cooling and power supplies. And there's also system management specification. So all of these are, are adopted by SOSA in certain subsections of each of those specifications, not the whole spec, but certain parts of each of these specs have been adopted by SOSA to do the best job for um, the mission at hand here, which is edge processing. Okay. One of the other interesting mandates that SOSA specifies is that all signals, analog RF, IO, and optical signals must come through the backplane. What this does is this makes the systems a lot more serviceable. It removes a lot of cables from the front panel that would otherwise perhaps be either an issue for service and repair, or it might even be something that could catch on someone walking by a chassis and disrupt it. So it's very safe and blind mated backplane connections for everything in SOSA. Here you see outlined in red, you see 20 different coaxial RF backplane cables and connectors. You see also two optical ferrules. Each of these optical ferrules can have 24 optical fibers. So this kind of I/O is really important for SOSA and also for reliability. Another standard that's been adopted by SOSA is the VITA 49 radio transport protocol, VITA RT. So this then gets away from all of the stovepipe architectures that were traditionally used for proprietary cabling and interfaces and the different kinds of connections, analog and digital, very specialized connections. And it's moving largely towards a network-based connectivity so that the different parts of the system can connect to each other through a switched network. And that then makes those systems much less dependent on hardware connectors and so forth, and just more standardized for reusability, flexibility, and insertion of new technology. What does SOSA really mean for uncrewed vehicles? It doesn't it doesn't specify the complete system, but it does specify what's inside of the chassis. So it defines, as we saw, the cards, the chassis, backplanes, cooling protocol, and so forth. And only a very few of the many profiles in OpenVPX have been adopted by SOSA. That's to reduce the number of different kind of cards and profiles, again, for interoperability. Ethernet is the primary interconnect between the cards and the systems. And so all of the payload data and the control data use VITA 49 across Ethernet to improve that interoperability. And all of the external connections from the SOSA chassis can go to external sensors using those Ethernet connections, so that the sensors can be just about anything, but the sensors need to be able to communicate to the SOSA chassis, and using Ethernet is definitely the standard way for doing that. Here's some new technology. This was introduced by Xilinx, now AMD, back around in 2017, 2018. We started shipping products using the RF SoC, or RF system on chip, and it's been extremely popular for edge processing, as well as for processing within a chassis as well. So what it has is it has 8 RF inputs and 8 RF outputs. So it's A to D converters, D to A converters, a very powerful fabric for FPGA configuration code, dual 100 gigabit Ethernet interfaces, other types of gigabit Ethernet, and an ARM processor for control. So it's got a complete RF system on a chip. So that's RF SoC, system on chip. And it's really ideal for radar and comm. The latency is low because the A to Ds and D to A converters are tied directly into the fabric of the FPGA. So it's been extremely popular choice. And this can go onto a 3U VPX card, but it also can be deployed at the edge using other products in this family, the RF SoC family. The product you see on the top there is an 8-channel IF or RF transceiver edge sensor. This can be mounted, say, up on an antenna mast outside, so it's suited for IP67, and can be then used in severe weather. It'll give you the ability to digitize and generate 2 gigahertz bandwidth signals on each of those channels. It delivers the payload data up and down through the 100 gigabit optical cable interface. It takes a single 24-volt power supply, and you've got GPS receiver built in to do time stamping and positional information. There's also a subsystem that is the inside of what's in that upper box that's available, so you can have the same functionality inside of another enclosure. This makes then a very nice way to get the RF SoC capability all kind of all done at the functional level as a subsystem that can be simply attached inside of, let's say, a UAV as an internal component. Another new technology has been the AMD Xilinx Versal family of products. And this is a adaptive compute acceleration platform. And what this has in it is multi compute engines, including scalar engines. You see the ARM processors over on the left, and then configurable FPGA logic, which give the adaptable engines, and then intelligent engines for that support AI functions and DSP engines over there on the right. Notice that all of the resources are joined together with a very high-speed network on chip, connecting the different blocks of processing engines to each other, and also to all of the peripherals that connect to the outside world. So this is extremely important family, and it's extremely well suited for the types of applications that SOSA is addressing. In this case, we have a 6U OpenVPX dual uh, AI core ACAP, like the one we saw before, with this heterogeneous processing capability, all ready to go into a 6U SOSA aligned chassis. Very, very high performance processing. And this would be a board that would go into, say, the processing engine chassis block. Another more recent introduction, just back last year in 2023, is the Intel Agilex 9 Direct RF FPGAs. Now, this is similar in function to the RF SoC that we saw before, in that this multi-chip module really contains the FPGA fabric and processors and the data converters, all in a single package. It uses a new advanced technology with 10 nanometer superfin process. And there are two devices shown here. One is a 4-channel input output that is A to Ds and D to As. And the one on the right is an 8-channel version. So these digitizers can receive, digitize, and generate signals, RF signals, up to 36 gigahertz signal frequencies, and can handle an instantaneous bandwidth up to 32 gigahertz. So tremendous coverage across a huge part of all of the important military bands that are out there. Very fast interfaces to the outside world, and the connection between the data converters and the FPGA fabric is done through a parallel bus called the Advanced Interconnect Bus. That's really important to reduce latency, very important for electronic warfare applications. So we wanted to take this technology into this space for for electronic warfare, radar, and so forth. And we decided to follow the same path that we did with the RF SOC, and that is to put this chip, this device, on a system on module. And so the system on module is shown here. We released this in January of 2024. It's called uh, the Model 20 DRF 2580, and it shows the processor in the center of that little module, but with RF connections on the right side. And you can see a photo of it over to the left. Those RF connections in and out. Digital and power come through a multi-pin high-speed connection. The beauty of this is that by being a small module, it can go into a lot of different form factors and shapes. Another part of what we introduced was a RF interface module that matches the same RF connections that you see on the system on module. They can have different personalities depending on the RF functions that you need to have between the sensor and the A to D, D to A converters in the system on module. Mercury also has a MMIC division that can provide a tremendous amount of very high performance RF analog uh, signal conditioning and processing and filtering, adaptive filters, switch filters, tuners, and so forth. Those can be very small because they're MMIC devices, and you can put up a very powerful RF conditioning front end right there in this small module. Now, this module and the RF module, both of these together, can then be mounted in a 3U carrier, on a 3U carrier, to make a 3U SOSA aligned plug-in card for a SOSA chassis. So you see a top-down view here where the backplane connections are shown on the left of the drawing, and down below you see a side view showing how the carrier board supports this. Of course, there will be RF cabling from the RF interface module through to the backplane P2 connections for analog RF and I/O. That's not shown here. So this gives you one example of how this modular approach can be used to create a 3U VPX carrier card. Now, this family is also going to consist of not only a 3U VPX carrier, but a PCI Express version, a rugged enclosure like the one we saw for the RF SOC earlier, very similar, and then an internal subsystem so that you can mount it inside of a UAV, for example, as we said before. And lastly, there's a custom system on module carrier design package with complete documentation so that customers can take this technology and make their own carrier product to fit the size, shape, and requirements that you might have in a custom application that might need to fit in a certain particular space for any given application. So this first product uses the 4-channel input output, And the next one, which will be the ARGW027, will have the 8-channel input and output. So this is, we're testing this product right now, and we'll be shipping it a little bit later on this year. So an example of a system could be that you have a sensor at the edge. In this case, we've got a sensor on a phased array mounted on top of an autonomous vehicle, where you've got a phased array antenna, and right behind the antenna, inside of the enclosure behind the antenna, you have the subsystem that could be either the RF-SOC or Agilex 9 subsystem that we looked at, connected to a chassis that would be inside the autonomous vehicle that receives and processes and generates the payload data over dual 100 gigabit Ethernet optical links that go up the antenna mast, and a 1 gigabit Ethernet link for control and status of that antenna subsystem on the mast. Inside the chassis, you have SOSA aligned 3U open VPX processing cards as required, all complying with the SOSA technical standard. So what are the benefits? Of course, we see at the top there, all of the MOSA requirements are really met very nicely. But one thing that's also nice is that lower tier vendors can create SOSA solutions rather quickly, often more quickly than the larger primes. And they can help those larger primes then get SOSA content into the program bids. That'll improve their chance of winning orders. So it's a very synergistic relationship to both the smaller companies, the larger primes, and of course, ultimately to the government customer who benefits from all of the nice things that are listed above. So just kind of to summarize where we are, SOSA now includes over 179 different organizations. There's 13 US DoD sponsors. There are 26 principals. These are mostly the primes, US DoD prime vendors, and then 140 other members that are tier 2 or lower suppliers or vendors that are all interested in contributing to the product family that our government's looking for. We talked about the technical standard. There's also a consortium effort right now to fully define the certification process, and to make a certification means that each of these products has been tested and certified to be fully compliant and conformant to the SOSA specification. DoD is using SOSA as a primary embedded standard in requirements for major programs of record. It's now being used adopted widely by suppliers, and it really does benefit a lot of the different operations, all the way from the procurement office all the way down to the war fighters in the field. And it really does give a clear long-term advantage to everyone involved in this infrastructure of defense. So that's what we have in a nutshell here for our edge processing SOSA. And you can go to our website and get some more information through these links. There's still some links also available on the Pentech website. So you've got a lot of different resources, publications. You can also join the SOSA organization. It's a great group, and it's open to US persons. And with that, I am done. Thank you very much for joining. I'm going to turn things back over to John.
Excellent. Good presentation, Rodger, as always. And we have tons of questions, which always seem to follow your presentation. So let's get started. First question is one actually that I ask a lot at these press conferences on SOSA. How is the SOSA conformance process progressing? Do we have one yet?
It's being defined. There's a lot of work, and a lot of that is being done in the business working group. The the task is you have to first of all get a complete specification with a conformance matrix and how each test for each product shall be conducted, and then a procedure for doing so. Once that's done, then a particular product that is SOSA compliant will have to then be tested by a third party. Those third parties will use the specifications and the test conformance matrix that SOSA provides. They will perform the tests and then get back with a report, either passing or failing the test. SOSA organization will review the report, and if it's favorable, they will then approve that product for certification, list that product on the website. So there's a lot of different pieces lining up. First of all, the spec, then the testing authorities, and then finally the getting the interface that's necessary for posting all of that information up on the website. So it's coming along. It's taken a long time, but it's taken a long time because it's very complicated.
And just a note quickly on for those who might wonder, conformance, compliance, things like that. It's a nomenclature that the Open Group uses. The Open Group puts who kind of helps run the SOSA technical standard as well as the FACE technical standard. If you're compliant to something, it means you can follow the guidelines yourself to make yourself compliant. Conformance means you have to conform to a system, and that someone else, a third party, has to provide that. So that's why there's SOSA conformance, and there's also SOSA align, which means SOSA sees you as having the ability, your product, to become conformant when the conformant process is ready. Did I get that right, Rodger? Is that pretty much?
You got it right. It is a little hard to know exactly what people are talking about sometimes because those terms have different meanings in different contexts. But as you said, SOSA has defined them very, very carefully. And to say that the certified, that means that it has been shown to be totally conformant to all the specs it's required of it. So you're right.
So along those lines, if I upgrade a SOSA system, do I have to have the system recertified, or I guess realigned or reconformed, or what?
Now, remember too, the answer is no. What happens is SOSA really doesn't certify the system. It certifies the parts of what goes into the system. So each card can be SOSA certified. The backplane can be SOSA certified. The power supply can be SOSA certified. The chassis itself can be SOSA certified, but uh, SOSA does not certify the system. Okay, so if you have a completely functional SOSA system and you want to upgrade it with a new processor card, you can remove the old processor card, put in the new processor card. If that new card has been shown to be certified, has passed certification, then you're good to go. So that does make sense.
And along those lines too, we have the recertification. You mentioned how the system is almost like with avionics safety software certification. You're certified an individual code, and when all those elements are certified, then the system might seem to be safety certified or compliant with a particular certification standard. Which is that similar, Rodger? I mean,
Yeah. Again, I think it is similar, but remember, the DoD customer may require some additional testing for certain critical applications, like safety or security, and so SOSA says, listen, this system is comprised of SOSA certified products, and that's where the SOSA specification and the technical standard ends. It doesn't pretend to do all necessary testing that a particular customer might require.
Okay. Got a question from the audience. What about the application of SOSA to uncrewed vehicles, which are not small regarding size, weight, and power? Like those old big Global Hawks or anything like that. How are you guys approaching that?
So obviously, anything that flies, there is some sensitivity to size, weight, and power. I mean, and it really, um, having it be large doesn't preclude it from benefiting when things are small. So a 3U VPX chassis is not going to fit into a small drone, but it could definitely fit in a Global Hawk, type aircraft, a large one. So SOSA really um, uh, plays where it needs to and how it needs to, as it's defined in the standard, and it doesn't exclude large platforms from benefiting. The main benefit of SOSA, again, is the interoperability, the easy upgrades, the commonality of parts, interchangeability. All of that can benefit systems that are very small to very large.
Okay, got a question here, Roger. I've heard this one before too. Doesn't SOSA make systems more expensive?
It makes them more expensive to start with, but it'll save money over and over again every time that system doesn't have to be scrapped for the next generation of technology that needs to be used and deployed. So it's a kind of a pay forward thing. You buy a system that is inherently reusable, reconfigurable, and that extra expense pays for itself over and over again every time that system needs to be upgraded.
And so, and along those lines too, in terms of uh, I forgot my follow up, so I'm going to move on to the next question from the audience. It happens to the best of us. Does the cabling and chassis requirements of SOSA set an effective minimum bound on the size of a UAS for a particular payload? If, for example, if a module reduces its size, weight, and power, would that break compatibility with SOSA?
Not if the interfaces are as defined by SOSA, primarily Ethernet. So, and the other thing too is if part of your system is not SOSA compliant, it doesn't mean that you can't sell that to the government. The government may be willing to buy a system that is mostly SOSA certified. And so if another vendor offers the similar function in a system that is 100% SOSA certified, he will have an advantage over the one that's partly SOSA certified. So in every case, there are exceptions, but the best what that does then it gives you that sense of competition and innovation to try to get as much SOSA content as possible in a system bid. That as far as the primes go, that's really they're really incentivized to do that.
This person had a follow-up question too. Can more generally, can hardware interface interoperability be maintained as its size is reduced? And I think you kind of answered that.
Yeah, the answer. I mean, you can have very, very small, those little small subsystems that I showed in the picture. Those are, you hold it in your hand. Um, those can have 100 gigabit Ethernet interfaces just as well as a full, 10U, 6U VPX rack would. So it doesn't. That really it is very scalable to a lot of different form factors.
Are you seeing the sizes? I mean, aside from what SOSA is working on, are you seeing requirements come in at all for sizes that are even smaller for some of these payloads as the footprint gets of the actual platform itself might get tinier, the handheld
Yeah, there
ones?
there actually is a committee on small form factor in SOSA that's working on exactly that. And what it will do is it will try to keep the SOSA principles, but uh, because this new small form factor is not part of OpenVPX, it could be based on another small form factor subsystem that could come from VITA.
Okay. Next question: how can SOSA systems adapt to higher RF signal frequencies, wider data bandwidths?
The nice thing about the connectors that we looked at I showed you the Vita 67.3 connectors, which have in P2, it has up to 20 coaxial RF cables. Those are based on aluminum housings that house the coaxial connections. And those housings fit into what's called apertures, which are cutouts in the backplane that can be removed and replaced with a different aperture, which could have, for example, larger diameter RF cables that then could have higher frequency, could handle higher frequencies. So again, even the housings for those backplane connections that mate with the plug-in cards can change as requirements change to go up to higher and higher frequencies.
Okay, I have a question. Just audience, keep the questions coming in. We've got time for more. I've got one here. Kind of references in an earlier session they talked a little bit about at the edge, and we're talking about from a software standpoint, like AI at the edge or at the edge. And so I think if you take the C5ISR, talk about the sensors, the platforms. What I heard was actually at a conference you and I both attended in January, Embedded Tech Trends, where a presenter talked about he saw AI, he saw at the edge from where our little world is, not just where you engage the enemy or the domain, but where the sensor collects the data. Would you agree with that? And how do you guys design with AI at the edge, or how does when you hear AI at the edge or AI processing, where does that mean to you as a designer or to your customers?
Sure. Well, the Versal ACAP that we talked about, and also the Agilex 9 FPGA that we talked about, both have AI capabilities and AI engines. And those then, being on small modules, can go up into behind the antenna at the edge. So that's how it can be done.
Oh, you finished. Okay, I thought you were about something,
Yep.
something else. No worries. So one of the earlier the question I forgot I was going to say, I did remember, was regarding the SOSA and the expenses and how but it also it's about not just it's the life cycle of the product. It is expensive to implement and it also it depends on requirements, but requirements are happening. But what I heard as an example was that for not just they take $50 million to upgrade this ground vehicles, vehicle electronics, but hey, you know what? If I have SOSA, I can just pull off what I need. It cuts down on the downtime, the amount of time that the system's taken off and not on the battlefield, and I can just plug and play it. Now it costs me $5 million. Is that kind of what that's an example I heard? Is that something that you've heard as well, or is that?
That's exactly the idea. That's exactly the intent of the SOSA and the reusability and new tech insertion.
Okay. And when it comes to MOSA and SOSA, you talked about it in your thing, but I often still hear people say to me, "Hey, John, I've been told my board's got to be MOSA compliant." I'm like, "Well, there's no such thing. MOSA is an approach. It's a strategy.
It's an approach. The A in MOSA is approach. And the SOSA is really the technical standard that is inspired by MOSA approach. It's the way to look at it.
What's the biggest misconception people have about it, SOSA or even MOSA?
I think the one that I tried to make a point about, and that is that SOSA is a system specification. We get, and if I build something, I'm gonna have to have my whole system certified, and I'll just never happen. And that is not the intent.
That would be very expensive.
That would be very expensive. And just imagine how long that would take. It takes people a long time now to do it. But what's going to happen is with SOSA on components, a lot of the testing at the system level is going to be easier because now they can focus on the overall function without having to worry about each component, the certification of each component.
And SOSA, I think another one I hear is SOSA is not just sensors; it's also mission compute and things like that.
Yeah, that's true. I mean, the first S in SOSA is sensor, because that is so much of what DoD needs for deployed electronic systems, and it does cover optical, infrared, a huge range of radio frequency signal frequencies just all over. So it's but also transducers, even maybe pressure transducers, other kinds of mechanical transducers could also be handled as well.
In the keynote presentation, we talked about how the paradigm shift within the battlefield and with Ukraine and everything, and how uncrewed systems have become, you're deploying them a lot more quickly than you would if you went through, let's say, the DoD procurement process, right? And how the DoD acquisition is never going to speed up. Do you think MOSA and SOSA, maybe not, they're not, I wouldn't say they're speeding things up necessarily, but they are providing more opportunities for um, people who companies that provide these components, these boards that don't traditionally participate with the new DoD? Is it giving them an opportunity, or giving the DoD an opportunity to see more state-of-the-art technology from commercial companies than they would have without it?
Right. I mean, I definitely agree with that, and I did make a point about the smaller vendors benefiting from SOSA because they can, if they're specialists in a particular technology, they can get it to market more quickly than a large company could, and the software and all of the other support for that particular function can be done by experts, and then the rest of the industry can take advantage of that expertise and that technology and get that in their product as delivered as part of a system to the government much more quickly and much less with much less engineering required on their part to do so.
I think it's also noticeable, at least from my point, when I look at the SOSA membership, you got Intel as a member. You've got,
Yeah.
which is now, I think it's going to be their Altera group, but I don't know for sure. They just spun off their FPGA
Right.
into a standalone company. Then you have NVIDIA as a member, believe it or not, of SOSA.
Right.
So you have that. I think I saw a graphic. I said from basically from the chip maker all the way to the end user, they're all
Yep.
participating in the process, which is unique. And isn't that kind of what there's a lot of skeptics out there. Why should I believe this is any different than any other DoD mandate that came along? Is it going to last a few years? I don't know. I think that's a good way of looking at it. And also the customers really pushing, your end users pushing for this.
Yep. No, I think all of the large semi companies are definitely want to be part of it because they want to be part of of the component end of the requirement. And if they have a component that's really a great, like the Agilex 9, for example, from Intel, that addresses so many military applications so carefully, and the way to get to be on a particular system nowadays is going to be through a SOSA developer's path. That's the way to get there. And so being involved in SOSA and having the interfaces that will make it easier for developers to make SOSA compliant and conformant products will be in their best interest. That's why they're doing it, and it makes sense.
Also, in our keynote, he talked a lot about the threats that are coming and how the defense, we talked about defense procurement is doing it, and how industry, how is Mercury looking at, from a technology standpoint, what's your game plan to deal with the requirements you're seeing to respond to these threats? Is it along the lines of SOSA, or is it more processing performance? What trends are you seeing, and how are you guys dealing with it?
Yeah, I mean, we're putting a major effort now into this latest family, the Agilex 9, across a couple of divisions of Mercury. We're all, working on it together. And once we have that technology tamed and understood and easily deployable in the form factors like SOSA compliant boards, we're going to make that technology available as an advantage to the warfighter. Um, it's just what it does is it it's a more quick reaction to new threats. And if you can develop configurable processing elements like configurable FPGAs, configurable software for AI engines, and work at higher levels of development with high level software tools, but working with such powerful engines underneath, even if those tools are not 100% efficient, they can get the job done and have an algorithm that runs in real time rather quickly compared to what was available just 5 years ago, and then that can be deployed. So the hardware now is becoming, there's so many different resources, different processor engines, and so much FPGA fabric that can be applied to, to a particular problem that, okay, maybe the tools, don't squeeze every bit of information, of processing out of all the information, but they can get the job done with the huge number of resources that they do have available.
Okay, I think I can go with one more question here. I got one from the audience. Does SOSA standardize interfaces for hardware reconfiguration like FPGA reprogramming, or is that coming?
In other words, to standardize the reconfiguration of FPGA
That's what it sounds like the question is. Yeah.
Yeah, I don't believe so. I don't believe so, because that is, typically a particular protocol and stream that usually is defined by the chip vendor as to, what kind of a reconfiguration bus, I2C or whatever it is that will do that. And I think that SOSA does not try to get into what might be a vendor specific, a chip vendor specific protocol for reconfiguration. After all, the configuration code for each FPGA is different because of the architecture of each different FPGA part that's out there, different families from different vendors. They have different hardware structures inside. And so a universal programming stream to configure the FPGAs probably just doesn't make a lot of sense.
Okay. And as we're getting close here, what is your Mercury Systems? I know I'm attending Sea Air Space next week, a big Navy event. I know Mercury is a booth there. Is there any other shows where folks watching can maybe check out your tech in person?
We're going to be at the CEMA show, CEMA show. That'll be down in Aberdeen. That'll be at the end of this month. We're going to be at the IMS show, and that'll be in June. Those are the ones that I'm aware of and attending.
Okay. And that brings us to the end of our time limit for today. So we're going to get to all of your questions. Someone may get back to you after the event with more information. I want to thank you, Rodger, for speaking today, and I want to thank Wind River for being our platinum sponsor. Please note this and all Open Systems Media virtual events are copyrighted and may not be recorded used in any way without the express written consent of Open Systems Media. This event will be archived online today at the same URL used to join today's live session, as well as the URL shown on your screen, and be available for at least 1 year. And please be sure to attend our next session, Navigating Safety Certification in UAS Platforms, which may be the most important thing of all, keeping these things safe so they don't crash into anyone. Starting at 2:15 p.m. Eastern. See you soon. Thank you all.